Okay, so first we're going to look a little bit at how Tendermint works. And I'm not going to go into a whole lot of details because Tendermint is super complicated. Well, debugging through Tendermint is an exercise because of the use of channels and a whole lot of asynchronous data passings, locks and semaphores and all that kind of stuff. It is not trivial to track how things happen through Tendermint. And the consensus process and all of this kind of asynchronous stuff is kind of a headache to wade through. So I'm going to be looking at it from the relatively superficial perspective of how do transactions get through the API into Tendermint, or through the API and Tendermint into the internal application. So if we look at one of these transactions, first we're going to be looking at things including Tendermint. I have to decide which one of these tests I want to debug. Okay, so let's look at this test. This has, oh no, that's going to be, okay, this one has multiple BVNs. So if you want to debug through how the process between multiple BVNs works, this is something you can look at, but I don't want to deal with hitting that many breakpoints right now. So I think we'll just go with the faucet. The faucet's a little bit weird, but we're going to ignore that for now. And this is also using API v1, so it's a bit different. I'm not going to go into that in detail, but if we, what about, I just want to make you guys listen to me try to make up my mind. Super fun, isn't it? Okay, I changed my mind again. Oh, I shouldn't have committed that. Well, I make mistakes like everybody else. Okay, so this is submitting transactions as submitting transactions between light token accounts. So here, this is constructing a send tokens transaction or withdrawal that will result in submitting, withdrawal, deposit, sending tokens, that whole thing. So if we look at the, okay, so we won't be looking at the API actually. We'll be, yeah, not gonna look at the API for now. So if we put some breakpoints, okay, so here we are, we're in the ABCI and we're hitting a transaction. Do I call transaction ID or transaction type? No, that only happens down there. Okay. So we can look, we're in the middle of a, we're doing the check. So check happens first. So check happens outside of the block. It's something that Tendermint does first when it first receives the transaction. And this is happening over TCP. So this is how it works more or less in the actual transaction processing. Did I lie? Yeah, I totally lied. This is not going through TCP. Okay, well, this is some test code, but in the test here, in the create account, we're submitting a transaction, and this is a fake synthetic transaction. And that's going to broadcast. So this is not going through TCP. This is going through the local client, the local RPC. Well, local RPC is kind of an oxymoron, but this is going through the local RPC client. And there's Tendermint's logic here. And so this is, if this was TCP, if this was going through the regular TCP, HTTP stack, you would see a whole bunch more function calls down here going through all the HTTP and JSON RPC stuff, and at some point it would be, the connection handling code, because you wouldn't be able to look at the test. The test function call would not be in the same stack trace because it's going through a TCP connection. So, this is going through that call and going through Tendermint's process. So going through the checktx and mempool, and again, I'm not going to dig into this in detail, but the check happens outside of the begin. And then if the transaction is valid, then Tendermint adds it to its queue. This is some Tendermint stuff. And again, there's lots of stuff happening. So this is happening in the Tendermint reactor. And this is some internal messaging going on. So it's calling checktx more. And I think this test is running with multiple networks. Yeah, this test is running 3 nodes. So this is the consensus process, I think, between the different nodes, and it's each. So when one node, when one node receives a transaction, it makes sure it's valid. If the transaction is valid, it then broadcasts it to the rest of the network, and the rest of the network is checking it. Because if node A gets a transaction from node B, it wants to make sure that it is valid and it's not somehow getting garbage sent by some middleman or something. And then we hit this breakpoint. And why is this? Okay, well, this is not going the way I wanted it to. Interesting. I'm going to assume that setting a breakpoint in the middle of the consensus process made everything sad. Let's try this again with only one node. So this is the call before, going through the local RPC client. Okay, now we get begin block. So yeah, if you set breakpoints and wait too long, you exceed the timeouts, and Tendermint's like, what? And gets sad and assumes that the leader has lost its mind. So here, we're doing begin block. So we check the transaction. Now we're in begin block, and this is happening in some Go routine in the middle of Tendermint, and then there's all kind of messaging stuff. So yeah, if you want to dig into Tendermint, great, but that's not code we're building, so I am not going to worry about it too much. And then, starting the transaction again. Okay, so we hit that other breakpoint because, oh gosh, I don't know. Let's get rid of that first breakpoint in the test, because that is just confusing me. Checktx, begin block, commit. The Go debugger can be weird. And sometimes it just ignores breakpoints. Okay, let's try this again. Check. And so this is, I expect, going to be the second the other transaction sent by the test. Nope, we're in the middle of some routine. Oh, yay. Yeah, no, that didn't work. Timeouts are fun when you're trying to debug stuff. Huh. Well, I'm not sure why it's not hitting my breakpoint in deliver, but this is obviously not going terribly well. So I'm going to give up on trying to debug Tendermint right now, or show you how that works. I mean, it's not particularly interesting. Check, it calls check, and then it starts the block and calls deliver inside the block. I mean, one thing we can do is I can go to config.
Mohammed asked to see the VS Code launch.json.
Oh, I'm doing a test debugging session. So this, I'm using VS Code, the Go support. So I'm debugging the test. So this is not relevant because it's not executing through the. I mean, I can send you the launch separately to but that's not what we're doing right now. This is running a debugger session, a VS Code. Well, it's debugging the Go test. So this configuration. This is launching the node. So this is just running a single node in. Oh, actually, no. This is running DevNet, right? Because I updated that. So that's the thing that runs all the nodes. And I can go through that too. But this is that launch.json is not relevant to what I was doing just now. But what I can do is show you what the logs look like. So first, you get the check, and each of these nodes is there's two nodes running here, and those nodes succeed on the check. No, what do I want to debug? Where's the one that begin block executor, I think. And I am begin block. Okay, that's debug message from the executor. So we're going to change this executor debug. And try this again. Okay, here we go. So this is the sequence of events. You got the check, and that's happening on both nodes. And then Tendermint starts the block, and then the deliver succeeds. So I guess because both, well, anyways, yeah, check, begin, deliver, commit, and then subsequent blocks. That's the sequence of events. And you can see some of it, but again, when you're debugging, you get fun with timeouts, and that's always exciting in the bad way. So I'm not going to spend a whole lot of time talking about Tendermint. You can see how transactions get through the API into Tendermint. And just to include the API, maybe, if we look at JSON RPC, if we do test faucet, this is using the API, right? Yeah. Okay. So do we have put a breakpoint back in check? So Mohammed, you wanted to see the local node config. Do you mean what configuration I was running those tests with?
No, I just meant the JSON file you tested with VS Code, but yeah, I'd like to see that as well, your local node config.
So when the test is running, and there's initialization happens in a couple of different ways, but we can look at in this particular test, we can look at start BVC, and most of the tests, well, I think all the tests actually run with this. They make this call. So they're using local BVN. Well, some of them are doing it with different IP addresses. But there's initially, well, so if you look at this test and we look at start BVC, then we can go into here, and this sets up some of the options, and then it calls init. And so this creates the configuration. And init is also what the init command runs. So when you run accumulated init, that is also setting up some options and running this. But in terms of the test, configuration is generated in the tests, and this here it's generated this way. And if we look at the node end-to-end tests, Yeah, it's calling init also with somewhat different options. And then it's loading the configuration and making some changes. So it depends on the test. Most of the tests mostly configure things the same way. In terms of what I was running here, you can look. I have these configuration files here, and we have some configuration here. But I mean, you can generate this yourself. So the command I'm using is just accumulated init devnet. So that I'm putting everything in the .nodes folder just because that's where I like to have configuration, and telling it 0 followers and no empty blocks. So this defaults to 2 BVNs, and the DN and both BVNs each have 2 nodes. So if we look up at the start, oh, well, we can look at the end too. So there's DN node 0 and 1, and there's BVN 0 and BVN 1, and each of those has nodes 0 and 1. So that's the configuration I'm using here. And the test configuration depends on which test. Okay, relaying. You want to talk about relaying? Okay. Yeah, I think that is important. So I think for this one, I'm going to want to run a bit simpler of a setup. So clear out the nodes. And I'm going to say validators 1, followers 0, BVNs 1. So just one BVN, one node for each network, which is just BVN and the DN. And I like no empty blocks because I don't like seeing a whole bunch of empty blocks going through when I am testing things. Actually, is that going to be useful? Oops. Not the keystroke I intended. No, I don't think that's going to be useful for showing you relaying. Okay, now, yes, BVNs is relatively new. I don't know, added that sometime last week. So if we look at here, if we look at help, there's number of BVNs, number of followers per subnet, which includes the DN, because you always have to have a DN. Well, that's not strictly true, but we're going to pretend like it is. And the number of validators. And then I'm adding no empty blocks because I don't like empty blocks. So yes, this flag is relatively new. Okay, so we have those, and I need to run 2 of the BVNs and the DN. So run nodes DN dash node 0. That's the DN. BVN 0, node 0. And I'm doing this individually because, what? Oh, I'm doing this individually since I'm trying to, debug one of them, so I don't want all of them running. And on boot, the BVNs send an anchor. Well, anyways, they send an anchor, so there's a synthetic transaction going from the BVNs to the DN when they boot up. Okay, so let's do some debugging. So for the local node, now we want this to be just run. And run nodes BVN2 node number 0. Yeah. What is this checking? Oh, where are we? Sending some synthetic transaction. Okay, so this is probably the anchor trans. Oh no, this is going through the signing process. Yeah, because that's fun. Okay, so if we want to look at routing, I am debugging BVN2. BVN2 is going to be listening on which IP address? BVN2 is listening on .4. So I need to set the API to .4. And then what is Faucet using? I think Faucet is, okay, Faucet is this command. Faucet is still using API v1. Okay. I'm going to fund this account with the Faucet. And then, because I think TX create is going through API v2. Yes, TX create is going through API v2. Okay, so that is gRPC execute. You know, let's look at the routing for and relaying. We renamed some stuff. It was router, and then it got renamed to bouncer, and then it got renamed to relay. I think router is the least confusing. I don't know. We can disagree on or discuss what we should call that. I've been calling it the router, but relay and router mean the same thing, or routing, because there is, in API v2, there is no longer a specific component that handles routing. Let's just look from the base. Okay, so we'll step through a query call. So is that using? Well, I guess I can also just make the curl call directly. Query chain, query TX history. Okay, so we're going to do a query TX history. And this needs to go to 4 if we're going to debug that. So if I'm doing query TX history, got a breakpoint here, run that, hit that breakpoint, unmarshal some stuff, can look at the request. We're looking for Acme. And Acme should get routed to the DN, but we haven't made that change yet. Okay, so now we're going to look into the routing, the relaying. So we have Acme, it's a URL. We're going to parse that URL, get the routing number from that URL, which, again, we take the host name, which is just Acme, make it lowercase. So all chain IDs are calculated from lowercase strings such that the URLs are case agnostic. And the equal method, this does a comparison. Equal folds is a Unicode thing for case insensitive comparison. SHA hash, convert it to an integer. So we have the routing number. The routing number is some obnoxious number. And then again, we have 3 BVNs, so we have 3 clients. So if we look at gRPC Go, we have the options. Options has remote. And so when this was constructed, it constructed. So remote would be the list of networks. And the names are not the best, but that comes from here. So in this call to new gRPC, options.remote is going to be this array. And so then, we're constructing a client for each one of those, and that goes in there. And wherever we create the query object, well, anyways, we pass that somewhere we pass those clients to the query structure, querier. I'm missing. Oh, okay, never mind. We asked the program to the caller to give it to us. Anyways, so the point is that this client here has an entry for each thing, each network. So this is a list of this configuration is a list, either a list of BVNs like devnet.zion or testnet.bvn0 that corresponds to the networks.go file, or it's just a straight IP address. And the networks.go, we're not going to have that for mainnet. That's a testnet type thing. So we have a list of clients, and if we look in the debugger, that list of clients, they'll have somewhere in here, there's the actual IP address that it's sending requests to, and we have some routing number. We do some modulo math. We say that this is going to be BVN0. And so the query dispatcher, or the query dispatch type, creates a query direct for that particular client, and then it forwards the call to that one. And so here we're in query direct, and this is sending it to this RPC client. And so we do some construction, construct the query, and this is going through the ABCI query method. And this is not going to, I can't debug this because this is not going to hit the local one. This is going to BVN0. But if we look at query, the query includes just a chunk of data. So we are marshaling the request, the TX history. We're creating a request TX history and setting some parameters. And then query is going to create a query.query and marshal stuff all together. And then this is the call. So we have this client, and this is going to BVN0, which is .2. And so this is sending the actual call. So that's dispatches, happening through this process, and it's getting sent to the appropriate RPC client for a node of the BVN that query is destined for. On the transaction side, let's see if we can actually see oh no, because I don't know which one that's going to get routed to. Okay. So transaction side, what are we going to be calling? If we do faucet, that's calling API v1. Oh, right, TX. Create TX, send tokens. Okay, so send tokens is implemented via execute with. Put a breakpoint here because Go is a little bit weird sometimes. So I want to do CLI. Well, let's make sure I'm using the current version. This is the account I funded, and we're going to send it to some random other account, and we'll send a token. Okay, so here we have execute with, and we have the payload coming in, parsing that payload. We have key page and key height and signer, signature, sponsor, all that good stuff. And then we are unloading the payload into a token TX object. And we have the from and the to. And we don't use hash or metadata right now, I don't think. At least the CLI doesn't. Marshal that, and that goes into execute. And you can also just call execute directly. One of the JRPC method or JSON RPC methods calls directly into this execute. So here, again, we're going to get the routing number, and that's going to be, we have the URL here, sponsor, which is this Acme account, and parse the URL, and go into routing, identity chain. We're looking at the host name, which is just the key, and taking the hash of that and converting that into a number. And then, routing, u.routing is going to give us some number. And then we're saying modulo the number of remotes. So we have 3 BVNs, BVN 0, BVN 1, BVN 2 is the one that we're currently debugging, so that's why that says local. And it is not the local one, because the local one is 2, so this transaction is getting routed to BVN 1. And if it was executing local, then this is going to go through the local RPC client and broadcast there. But since this is not local, do some marshalling, and we're going to be the leader. And so this is the batching of transactions in API v2. We either wait for queue duration, which is 1/4 of a second probably. This is in nanoseconds. Yeah, I think that's 1/4 of a second. Or number of transactions set to 100. So wait for 1/4 of a second. That was short. And then we have a queue of transactions, which is only the 1 because nobody else is sending transactions to my local machine. And it goes through, we have to break this up into batches. So we're going to make batches. So we make an array with 1 entry per remote, iterate through the queue of transactions. For each one, make a RPC request object, add it into this lookup structure, and append it to, right, okay, so if we look at this queue, the object in this queue specifies that it goes to BVN 1. Anytime I say BVC, translate that to BVN. I'm trying to purge BVC from my vocabulary, but it's going to take some time. So this transaction is bound for BVN 1, and here's the message. There's the raw JSON payload. So we batch them up per BVN, and there's only 1, so we're only going to have 1. So there's BVN 0 and BVN 2. We don't have anything to send to them. This is the transaction we have to send to BVN 1. And then it does the RPC call. So this is going to call execute on JRPC. And execute is going to go in here. And then because we're sending this batch to BVN 1, so BVN 1 is going to see that it is receiving a transaction destined for its local node. So BVN 1 is going to be hitting this point here. I am going to continue on talking about how the application works, and we have 20 minutes left. So, okay, so in terms of debugging, well, first of all, I'm going to shut down these. In terms of understanding how transactions are processed, the ABCI end-to-end tests are my go-to because this avoids all of the complication of Tendermint. So if we're going to look at, I want to look at something without a synthetic transaction first. So if we say add key, so here we're just going to step through this particular transaction. So we're adding a key. This is some test initialization. Set up the application, create some keys, set up the records we need, and then this creates a update key page transaction that adds this key to this key page. And we could call this so that's a little bit clearer. So we're adding key to this key page, signing it with the key that's already in the key page, and adding this new key. Okay, so I'm going to put a breakpoint in check, and if you debug this and look for the Tendermint code, instead of Tendermint, you get my test harness, which isn't going to tell you a whole lot. So we can look through the stack here, and here's, oh, yeah, okay, we're in the Go routine funness. This is all test harnessing. This is not Tendermint. This is pretending to be Tendermint, but this is code that I wrote to make tests possible without using Tendermint. So it's, I don't know, kind of a Tendermint simulator for a single node, maybe. Anyways, we're in checktx. You know, that transaction got sent here. And, you know, well, no, that doesn't matter. That's all test harnessing. Point is, transaction got sent and made it into checktx. Unmarshal it, because again, it's just a blob of bytes. And we get our nice data structure out of that. Go into check. This is some basic housekeeping. Yeah, those are already set. So if the routing, and these are transient fields on the transaction, if routing and chain ID haven't been set, then this sets them. Check. So check TX. Make sure it has signatures, because every transaction has to be signed. Validate those signatures. So we're going to iterate over the list of signatures and make sure, because the transaction includes keys. So the originator of the transaction has to include the public key so that we can actually, you know, verify it. So we're verifying if that signature matches the transaction that we received. And this is a update page transaction. And create a new state manager. Transaction has this URL, foo page 1, make sure that's a valid URL. And then we're going to grab the chain ID and put it into this field. And so this is the resource chain as opposed to the identity chain. So the resource chain means that's usually what we mean when we say chain ID. So in this case, the URL is foo/page 1. So the chain ID is going to be a hash of that entire thing. And if we look here, we have hostname plus, and this just makes sure that if there is a path that we add a slash to the path. Because you could create a URL structure that doesn't have a slash in the path. You know, you could manually construct one of these if you weren't using parse. And then do the same thing, calculate the chain, put it lowercase, hash, etc. And then we're loading this out of the database. You know, so this, we're looking for foo page 1. So this, you know, the sponsor of this transaction has to exist. You know, you can't, you have to, something has to be created before you can send transactions as that thing in most cases. So we're going to look in here and we're going to do some loading, and this is a cache effectively. So if we load a, you know, if we load something, we don't want to load it multiple times. And we're going to get the record out of the database. And again, this is looking in the next level of cache, which is not in there because there's nothing in cache right now. So we're going to go in the database and look up the record. So we're looking in state entries. You know, I have this chain ID, which is a hash of that URL. And we're getting data out of the key value store and unmarshalling it into an object data structure, which has the raw data of the key page plus some Merkle state information. And then we need to know what this thing is. So we can look, you know, at the, well, so we have this object, and object has a chunk of data. That chunk of data includes a chain header, so we'll pull the chain header out, get, you know, it's a key page and the URL and the key book that manages it, etc. And we know this is a key page, so we can unmarshal it as a key page. So now we know we have a spawn. We have the. I would like to rename this to actor So the transaction has an actor that is doing the action. Right now it's called sponsor. So the sponsor or actor is this key page. So now, we have the sponsor. We've pulled that out of the database. We parsed the URL, got the chain ID, pull it out of the database. We have this key page. Key page has keys and some other fields. And there are certain, for a synthetic chain create or synthetic deposit tokens, the sponsor is allowed to not exist. But for the most part, the sponsor has to exist, but it does, so we're fine. And it's not synthetic because synthetic transactions get verified in a slightly different way. So this is a add key sponsored by the page. So we say, we have a sponsor. What is our sponsor? What kind of thing is it? Well, it's a key page. And so that key page specifies everything that is a sponsor has a key book, except for key books themselves, which are their own sponsors, or which are their own governing key page. So the chain header says this record, foo page 1, is managed by some chain ID. So we're going to pull that out of the database, make sure it's actual thing. So now we have the transaction, and we've determined what record it's sponsored by, and we have the key book that manages that record. And then the transaction specifies the key page index, which is 0. And if the key page index is more than there are pages, then that's not valid. And then we're going to get the page, which happens to be the same record, but that's usually not the case. But the key book, has an array of chain IDs of all of the key pages. So we'll load the key page specified by this. We'll load the first, the 0th, the highest priority key page. And then get its height out of the database to make sure that the transaction, the height that the transaction specifies, the key page height, matches the height of the actual record. And then we will look through that page to find a key that matches the public key provided by the caller, which we found one. Yay! Make sure the nonce is right. Update the nonce. And again, this is, when we say update nonce, this is caching things. So if we go in here, this is not immediately actually writing anything to the database. So we're storing this record as it is updated, and we're putting that in this map here. So this is getting added to the cache. So now if the transaction later pulls that out, then we'll get the updated version of it. And this is the update key page. So we get update key page transaction. So we get the update key page executor, and we go through that. And we're kind of running out of time, so I'm going to skip through this a bit quickly. But this is update key page. We do some stuff, and we validate some things, and we update some records. So here, loading records, validating, making sure everything is sane. This is an add key operation. So we're going to just append it, take this key, take the new key, append it to the list of keys, and then update the page. And again, this is going into the cache. So this is writing it into this map on this object. And then we validate it. And so this, the state manager, it has some chains in here. It has some chains that could be written out to the database, but this is check. So check TX, we're not going to do any of that. We're not going to actually validate it, or we're not actually going to execute anything, because this is just verification. And if we go to deliver, deliver all the same things, runs the same code, well, there's some extra stuff here, but at some point we're calling check. Oh, and that hit that breakpoint that I left. So we call check, and then we get above somewhere we got the actual transaction executor, validate, and again, we have the updated records here. more housekeeping, and then commit. We're actually going to write this stuff out. So we go over the list of things that need to be written out to the database, and there's various constraints. If it's update, change, or create, etc. Oh, sorry. Well, we can go back to that or not. So there's the add state entry here, and that's putting something into yet another cache. Where are we? And then, and so that's the deliver process. And then eventually we get to commit, go into commit, and write some stuff to the database. Commit updates, is that the one? Yeah, okay. And then we're gonna, so we have the list of updates, and we're gonna start writing those updates out to the database. So this is adding the transaction hash, the hash of that transaction we're running. This is adding it to the Merkle tree, right? This command right here adds it to the Merkle tree. And I'm not going to go over this, but this is the Merkle tree logic. And then we have that state, and the update, because we added a key, so the key we added is going to be in this new state. And then we're writing that out to the database here, to the state entries bucket and the chain ID. So we're writing that out, and then we're also writing it to the BPT. And this state includes the state data here, current state, state data. This includes the Merkle tree proofs. So this includes the hashes and the height of the Merkle tree. So when we added hashes here, that updated the count. This count is coming from the Merkle tree, and these are the roots, and we're getting all the roots of the Merkle tree. And there's some fancy math here, but yeah, we're getting those root hashes of the Merkle tree and putting them into the state. So when we marshal the state, that includes all of those cryptographic proofs. Well, enough data to do the cryptographic proofs and put into the BPT. And this, this is going through some other caching. I mean, at some point in time, this is going to say put batch on the database. No, that's something else. Write batches. So here we're actually writing stuff out. So we have all this stuff. Again, there's like 3 layers of cache. So we have the stuff in the transaction cache. This, we write it out to the database. All right, we have 5 minutes for questions. So, any questions right now?
Well, no questions from me, but I do appreciate it, Ethan. That's really insightful.
It was a pretty good flyby, all the code. Well, one of the lessons is to find these unit tests that give you entry points that are somewhat bounded instead of the whole protocol as a great big lump.
There are some tests for the individual chain validators, but I mean, you can, we can have tests like we have, there's synthetic token deposit test, but the token deposit. I mean, if you wanted to, we could write a whole bunch of tests that go through all the different validation paths, and probably should for the synthetic token deposit. But if you want to understand how everything works in a more holistic way, that individual test isn't going to tell you how stuff gets into the database. Now, we could write tests around the executor, the top level executor, and that would skip the ABCI stuff and those intermediate things.
I do think that that's somewhat valuable to be able to use the test to see how a transaction is created and inserted into the system, which is what the end-to-end tests do. Mm-hmm. And it's always good to be able to, push the application and have it do something in order for you to get an understanding of how the code works together, because there are a lot of things that are done in this code side by side with perhaps something you're interested in. And so I think the end-to-end tests are really useful.
Yeah, and just FYI for the new people, well, I guess for everyone, synthetic transactions are all sorts of complicated now. So the process to sign them and make sure that all of the nodes agree on the signature and send those is kind of involved. And we can talk about that another day, but if you look at if you look at the file executor_synthetic, there are a number of methods in there. There are 5 or maybe 4 main entry points. And there's add synthetic transactions, add anchor transaction, sign synthetic transactions, and send synthetic transactions. Those are the synthetic transaction processing. And if you look at executor.go and see where those are called, you can start tracing how things flow through the system. If you just want to ignore it, you can ignore it for now because it's kind of complicated and kind of snaky.
I got 2 questions. First, about all the anchor chain commits that you've been adding. How are you integrating anchor chains into all of this? Because I just wanted to be up to speed about the anchor chains too as well.
So the anchor, so there is an anchor chain. Well, there'll be a minor and a major. So where is that? StateDB. Just quick. I mean, if you look in commit, StateDB commit, there's a write anchor chain, and this is writing out the anchor chain. And you can follow this through here, but this is where all of the anchors from all of the updates. So we look at all of the things, all the chains that got updated in the last block during this is during commit, and write all of those to the minor anchor chain. And then in executor begin block, we say add anchor transaction. So this add anchor transaction in executor synthetic is responsible for constructing the synthetic transaction that sends the anchor from the BVN to the DN, or vice versa, actually. And that constructs a synthetic transaction and adds it into the database, and then the actual signing and sending, that's tied in with the regular synthetic transaction process, and that's the one that's kind of messy. So that's probably something we should go over in the future. But yeah, for now, all right, I'm going to, Sandra asked a question. What is this? Is there support for BVN failover? No. There is no kind of handling of that sort of error. In fact, right now, if a synthetic transaction fails to go through, it might just disappear, which that's not terribly hard to change. But yeah, so there is no handling of failover or anything like that.